and bigger. And the answer is kind of surprising. At least I think so. What happens is this limit, as n goes to infinity, of 1 plus 1 over n, all right, so this quantity here, as n's getting bigger and bigger, this gets closer and closer to a number that we call e. Okay, so this is a number e. And you can't write down e exactly, but what I can tell you is e is approximately 2.71, right? You can take your calculator and press the E button, and you'll get this to maybe 12 digits or something like that. So what's going on here? So again, what's going on here is as n gets bigger and bigger, 1 plus 1 over n to the n power gets closer and closer to this number that we're calling e. Okay? All right, so why do I mention this? So when we left off at the end of lesson 5, we ended with this formula. A of t, so this is the amount of money that we have in a bank account after t years. This is equal to p, our principal, times 1 plus r divided by n times 100. Okay, so that r is the percent interest paid annually. N happens to be the number of interest periods, and this is being raised to the n times t power. Okay, now what happens? So here's what we want to know. We want to know what happens to the amount of money that we have in the bank after t years as the number of interest periods gets bigger and bigger. So we have more and more compounding. We have semi-annual compounding, we have monthly compounding, we have daily compounding, we could have hourly compounding, compounding every minute, every second, and so on and so forth. So we want to know what happens, what happens to A of t as n, the number of compounding periods, gets bigger and bigger. Oops, I should put that here. And then I'm going to erase this and go back. So there we go. Okay. All right. What I'm going to do is this. So definitely I'm going to use the fact that the limit as n goes to infinity of 1 plus 1 over n to the nth power is equal to this number e. Certainly I'm going to use this. But what we have in here is not just 1 over n, there's something being multiplied by 1 over n. So what I'm going to do is I'm going to do this. I'm going to set 1 over, let's call it m, okay? 1 over m is equal to r divided by 100 times n. Okay? So now I have A of t. So I'm just setting this. So I'm saying 1 over m is equal to this quantity here. So that means that I can write A of t as p times 1 plus 1 over m. That's kind of nice. 1 over m. And then here I have n times t. Well, notice that n is equal to r divided by 100 times m. So I'm going to put that up here. Instead of putting the n here, instead of putting the n up here, I'm going to write m times r divided by 100 times t. Okay? Now this is equal to p times 1 plus 1 over m to the m power, all raised to the r divided by 100 times t power. Remember, hey, you have to remember this. This is one of those exponential laws that's really important. If I have a to the xy power, so this is kind of an aside. If I have a to the x times y power, this is equal to a to the x, all raised to the y power. And that's exactly what I'm using here in order to write a of t in this form. Okay? Now, as m, so let me go back. Let me go back. We have 1 over m is equal to 1 over, no, it isn't. It's not 1. It's r divided by, that's an r, 100 times n. Okay, that's what we set m, that's how we defined our m. So I can write this equivalently as n is equal to r over 100 times m. Now, the r over 100, that's a fixed number. The interest rate is fixed for all time. That's what the bank pays. The 100 is fixed. That's 100. Now, as n, the number of interest periods, as that gets bigger and bigger and bigger, what happens to m? So as n gets bigger and bigger, so does m. Okay, that certainly makes sense. If n is getting bigger and bigger, then so is m. It's getting bigger and bigger. So that means we have a of t is equal to p times 1 plus 1 over m raised to the m power, all raised to the r divided by 100 times t power. If m is getting bigger and bigger, in other words, another way of saying this is m approaches plus infinity, then we know from our little limit formula that we wrote down. This is again, this is a formula that you'll see in calculus. This is equal to e. Okay, so a of t is equal to, in this case, this is equal to, I'm going to write it this way because this limit notation is really important. This is big time stuff in calculus. So this is r divided by 100 times t. My r's kind of look like my n's. Okay, well, what happens? So the limit here, as m gets bigger and bigger, as it approaches infinity, this quantity in here approaches e. So this is equal to p times e to the r divided by 100 times t. And this is called, so this scheme of paying interest is called continuously compounded interest. payments. All right. So this is really important. So if you see a savings program that says 10% annual interest compounded continuously, put all your money in it. Just kidding. Then after T years, if you put P dollars into this program, then what you would have at the end of T years is going to be 10 divided by 100 times T, which is equal to P to the E, P times E to the 1 over 10 times T. Okay. So in 10 years' time, if T is equal to 10, A of T, or A of 10, would equal P times 2.71. I think the next number is 4. I'm not sure. All right. Okay, that ends this lesson.